So today we're going to be looking at a laboratory technique called titration. We're going to be using an acid-base titration to kind of introduce us to this technique. And the goal of this titration lab is to identify the concentration of 2 hydrochloric acid samples. Now, you do not know the concentration of these samples, so we need to use a titration with a known concentration of a base, in this case sodium hydroxide, to identify and calculate the concentration of our 2 unknown acids. So here's what we've got. We have sodium hydroxide, a strong base that is monohydroxic. So that means for every 1 mole of sodium hydroxide, we have 1 mole of hydroxide. We have 2 samples of acid. This is both hydrochloric acid, and we do not know the concentration of either one. We also have an Erlenmeyer flask. Now, this Erlenmeyer flask is where the titration is going to be performed. We're going to perform the titration on a magnetic stir plate. I like the magnetic stir plates because it means that the stirring is going to be continuous and you don't have to do anything to make sure it's well mixed. We're going to be using phenothaline. Phenothaline is an indicator. This is an indicator that's used very commonly with these neutralization reactions because it changes color right around the equivalence point for our strong acid, strong base titrations, such as the one we're doing today. We're going to be doing all of our measurements initially in a graduated cylinder. This is a very accurate way of measuring our acid. So we're going to be measuring our acid into a graduated cylinder and then pouring it into our Erlenmeyer flask. Next, what we're going to do is we're going to take our base and we're going to use a Buret. Now, a Buret is the single most precise instrument that we can use in a titration because what it will do is it will not only just measure one volume precisely, but it will measure a range of volumes precisely. This is why we use Buret for many volumetric measurements in this class. A volumetric flask would not be effective because of the fact that volumetric flasks only measure at 1 volume. We need something that can measure very precisely at a range of volumes, such as a Buret. So let's talk about some techniques we need to do to prepare for this titration. Now, the first thing we're going to do to prepare for a titration is we need to make sure that our Buret is not contaminated in any way, shape, and form. You do not know what was last put in a Buret. And for that reason, whatever might have been in there could either react with or overconcentrate the base. So for that reason, we need to do the first thing, which is called conditioning the Buret. So let me show you how to do that. Okay, now that our Buret is conditioned, we are going to go ahead and fill the Buret with sodium hydroxide, our 1.00 molar solution. Okay, now that the Buret is filled, what we're going to do is we're going to take our first unknown acid. This is going to be acid A. We're going to take 50 milliliters of our unknown acid and we're going to put it in our Erlenmeyer flask. Now, just so you're aware, the measured volume of the acid needs to be extremely precise. Make sure that whether I ask you for 50 or 25 or any other volume, what matters the most is that the volume you record is precise to what you actually poured. Okay? Don't just put in 50 haphazardly. Measure the exact amount that you poured, because in the end, the math will work out. If you, in fact, use the exact amount that you claim to have used, the math will be more accurate. Now that we've measured and poured the acid into our Erlenmeyer flask, we're going to put just 2 squirts of phenothaline. Doesn't have to be a lot because it's going to be a very, very, very densely pink solution when it happens, but you do need enough to turn it pink, so just a couple of very quick squirts of phenolphthalein into our Erlenmeyer flask along with the acid. Whatever you do, do not add the phenolphthalein to the Buret with the sodium hydroxide. It will immediately turn pink and it will ruin my Buret. Do not do that. You're only putting the phenolphthalein into the Erlenmeyer flask with the acid. Now that we've prepared our titration, what we're going to do is we're going to go ahead and start the titration process. Measure the exact amount of sodium hydroxide in the Buret that you start with. Okay, so that's going to be your initial volume. You are then going to add sodium hydroxide into the Erlenmeyer flask while the magnetic stir bar is spinning, and you're going to continue adding it very slowly, drop by drop, until the color changes to pink. Now, in this titration, that will represent our equivalence point and our end point. The equivalence point, remember, is the number of moles of acid that you started with, or H plus that you started with, is exactly equal to the number of moles of OH minus that you added. Those two things are equivalent at the equivalence point. This is the end point for us because that is where we are going to have the change in color of our indicator, which means we end the titration at that point. In future titrations, we might decide to end the titration at a different point. So therefore, remember that end point and equivalent point are two different things, but sometimes they happen at the same place. I'd like to thank Berwin Lan and Jessica Wong for writing, filming, and editing this video. I'd like to thank you guys for watching it, and I'll see you in the next one. Acids that we're dealing with. Hang on. Sorry, Lily. All I can hear is your crinkling wrapper. Do you actually mind like hanging out in the other corner so that you can actually eat? Titration. No, I don't like that. Hang on. I got different iterations. That was the measurements in this class. A volumetric cylinder, in this case, is going to be really helpful indicator. This is an indicator that's going to change pH somewhat pointless. Not pointless, that's not the word I want to use. It's going to be Buret is conditioned. What we need to do is measure out our volume of sodium hydroxide. Lan and Jessica Wong for filming, for writing. All right, okay. Now what?